Okay, so I wanted to go over some of the theorems related to circles that we talked about in class. So the first one is the central angle theorem. So the central angle theorem states essentially that the central angle of a circle is equivalent to the measure of the arc that it intercepts. So if you have a central angle, so you can clearly see that this connects to the center of the circle that would identify it as the central angle. And you can clearly see it intercepts arc AB. So the measure of the central angle is also, so angle AOB is also 82 degrees. So if the measure of the arc's 82, then the central angle is 82 as well. So we can use this, pretty easily. To solve the problems that we see on delta math. So in circle C, it says with measure of angle BCD equivalent to 48 degrees, find the angle measure of minor arc BD. So the minor arc means an arc less than 180 degrees. So we're referring to this one. And the central angle is 48. So if the central angle is 48, then the measure of the arc also has to be 48 degrees. It's pretty much as simple as that. Later on, we may ask, for the major arc, but in this case, really it's only used to find minor arcs on this particular assignment. All right, so let's look at some more examples. Okay, so we also have some problems on inscribed angles. So inscribed angles differ a little bit from central angles because they essentially connect to a side of the circle. So the vertex will be located on the outer edge of the circle. Okay, so you see here an inscribed angle of ABC. We know it's inscribed because the vertex is on the edge of the circle and not at the center. Okay, so we can clearly see that. An inscribed angle is equal to half of the intercepted arc. So if we're given the arc of 82 degrees, then the inscribed angle, angle ABC, is half of 82. So one half, you can do 1/2 times 82, or you can just divide by 2, which is the same thing. So angle ABC is 41 degrees. Okay, so how do we use this in a problem? Well, let's read it first. So in circle G, with the measure of angle FJH as 31 degrees, find the angle measure of minor arc FH. So we're looking at this arc right here. Okay, so in this case, we weren't actually given the arc. We were given the angle. So let's go back really quickly. Well, what if I gave you this one and I said, okay, well, the angle is 41 degrees. So we would do the opposite of dividing by 2. So we could say that the arc measure is 2 times the inscribed angle. So we can say the angle, right, the inscribed angle is equal to half of the arc, or we can also say that 2 times the inscribed angle is equal to the arc, right, the intercepted. Let's make sure I'm spelling that correctly. Intercepted arc. Okay, so we can use that as well. So in this case, we're given the inscribed angle. We're asked to find the arc. So we're simply going to say, okay, well, arc FH is going to be equivalent to 2 times the inscribed angle, which is 31 degrees. So arc FH is 62 degrees. All right, so one more example. So in this case, it says in circle S with the measure of minor arc RT equals 46 degrees. So in this case, we're given the arc. Find the measure of angle RUT. So again, the first thing we're going to want to do in this particular assignment is decide, okay, is this a central angle or is it a inscribed angle? And you can clearly see it's an inscribed angle because the vertex is on the outer edge of the circle. So a central angle would be like if it was like something like this, where it connected at the center. So it is an inscribed angle, so we're going to use the inscribed angle theorem. And in this case, we're given the arc, so we're going to say that the measure of the angle, RUT, is equal to the arc divided by 2. So 46 divided by 2. So angle RUT, I don't know why I wrote A. Angle RUT is 46 divided by 2, so 23 degrees. Okay, let me know in the comments if you have any questions or any comments, and hope to see you at the next video.